Hello there. Um, so, welcome to our next sequence of remote learning modules. So, what we're going to learn about today is we're going to learn about variables, data types, and input output. So, I'm going to bring up Codio because I think it might be kind of interesting to try and experiment using Codio and some comments to see if we can get this all to work. So I call that first program lecture as my project, but I think what I'm going to do is go in here to section A, but it would work fine for section B as well. And I'm going to create a new project, a new file, and I'm going to call it variables, data types, IO notes. Okay. And start right here. So actually, now that I'm thinking about it, I think what I want to do instead is create a program. So you could create this program along with me. That would make a lot of sense. So why don't we try that? So we're going to create a program and we're going to call it football.java. All right. So I'm going to write a football program. So to write the football program, the name of the program is going to be public class. And what do you think the name of the program should be? So think about this for a second based on that first program that we wrote. Remember that first program was called myfirstprogram.java. It's right here. So the football program, if we look at myfirstprogram.java, remember it said public class myfirstprogram. And the name myfirstprogram had to match the name of the file myfirstprogram.java. So for the football program, we need to do exactly the same thing, public class football. And also remember, when you save the file, it has to be saved as football.java, not just football. Otherwise, it won't work. So public class football, and then I'm going to do an open curly bracket. And so I have a pair, open curly bracket will start the program, close curly bracket will end the program. And then we have to do a public static void main string args. And he does square brackets right there. And then I have another pair of curly brackets. So open curly bracket, this is the code after that open curly bracket. This is the code that's going to make the program actually work. Now, there's a lot of stuff that goes into computing the score for a football program, an American football program. So I just want to keep it simple and keep track of the number of touchdowns that happen in the game and the number of extra points that happen in the games. The extra points can occur if you make a field goal after you've done a touchdown. And there's a lot of rules for how that happens. So we're just going to keep it simple. We're going to assume that for a touchdown, you get 6 points if you get a touchdown. And if you get any extra points, it's just 1 for 1. So if you get a field goal, you just get 1 point. Now, it's more complicated than that normally, but we want to try to keep the program kind of simple. So in order to keep track of the number of touchdowns and the number of extra points, what we need is a variable, all right, inside the computer program. I mean, I guess we could hard code that information, but really it would be much more helpful to have a variable. And so in Java, we can have variables represent data that we're working with. And the way we do that is we declare the type of the variable. In this case, I'm saying the variable is type int. So int means that the variable is an integer. It's a whole number. So I'm going to call this variable touchdowns. Now I could have called it x or anything that I wanted to, but I think the variable named touchdowns is quite meaningful. It means that this variable stands for the number of touchdowns. And we'll say that there's 2 touchdowns for this amazing Skyhawks game. All right. And then we want another variable that represents extra points. So can you think of a good variable name that represents extra points? I'm going to declare the type of the variable as int or integer again. So this is all new stuff, right? That declaring a variable, declaring the type of the variable. Also notice I put a semicolon at the end there because almost every statement in Java ends with a semicolon, with just a few exceptions. So what is a good variable name for that represents extra points? We could type field goals. That might be useful. We could also do X. That could represent it. But since the variable itself represents the number of extra points, I like the variable extra points. So we'll have 3 extra points. Now notice I just line those equals up. You don't have to, but I think it makes the code looks nice and it makes it easier to read. Okay, so we have some basic information now. So what we're going to do is we're going to do a system.out.print line. And I'm going to put a string here that says the number of touchdowns is space, colon space. So Java will not interpret any of this. It will just print out the string or the text, number of touchdowns is, with a space after that colon. And then I'm going to add the plus sign here. What the plus sign lets me do is add variables into the system out print line. So if I say touchdowns and put a semicolon here, then what it'll do is the system out print line will say number of touchdowns is touchdowns, and it'll take the value of touchdowns and print it out on this line. So what is the value of touchdowns? Well, don't say 12 because it's not 12. We're counting the number of touchdowns, not the value, not the number of points in the game because of those touchdowns. So the number of touchdowns is 2. So it'll say number of touchdowns is 2. All right. And then we're going to do a system.out.println number of extra points is just lining this stuff up again, extra points. I even put a space there as well. I don't know, I'm just kind of playing with that. That looks nice. Okay, extra points, semicolon. So this line will print out the number of extra points. It'll say the number of extra points is, and it'll print out the value, the current value of extra points, which is 3. So it should say number of extra points is 3. Okay, so what I'd like to do now is I'd like to compile this and see if I can get it to execute. Now you could follow along with me and do this too. If you have a problem, since I'm not there with you, I can't debug it, but I want you to make your best effort to see if you can figure out what the error is. You probably want to look really carefully and compare character for character everything that's in the program that I have here with the program that you wrote. And there can't be a single character missing, or there can't be any extra characters or anything like that. So you're going to really have to carefully compare what you wrote to what I wrote. But this would be a really good moment to give it a shot. Also make sure that this thing is called football.java, then the capital F and every other character is lowercase .java, and make sure this is called football, capital F, and everything else is lowercase. So if all that stuff's set up and you press compile and run, what you should see is a compile of football.java and Java football to run the program, and you see number of touchdowns is 2, number of extra points is 3. So that should make a lot of sense. We're just printing out the values of touchdowns and extra points. All right, let's go back to football.java. Now, what I'd like to be able to do is I'd like to compute the score. So I'd like to say system.out.println score is plus score. Okay, now I just put this value score here, this variable score. I have not told Java what the variable score is yet, and I haven't told Java how to compute it, but let's just, for fun, let's just try to compile and run it and see what happens. Oh, look at this. We tried to compile it and then run it, and we got an error. It says football.java11 error, cannot find symbol. And it says system.println score is plus score. So there's a lot of clues here as to what the problem is with the program. So football.java11 says on line 11 of the football program, and here's the contents of line 11, there's something funny going on with this variable score. So what it means, what the error means, what the error means is that it can't find the symbol score. So that's Java's way of saying, hey, you tried to use a variable called score, but you haven't told me what that variable is. Like you haven't declared what its type is. Every variable in Java has to have a type, and you haven't set a value to that variable either. So let's do that right here. Let's say int score, and now I've declared the variable score. And let's see if that makes the program happy. Compile and run it. And now we get another error. So it says on line 13, the variable score might not have been initialized. So system.println score is :score. Huh. So it doesn't like line 13. So let's look at line 13. Well, I guess that makes sense. I declared this variable integer score. So I said score is of type int. But when I try to print out its value, how is Java supposed to know what the value of score is, right? Like, if you declare a variable x, what is the value of x? If you then immediately try to use x in some kind of equation, or say in some kind of equation or expression, and this is an example of an equation or an expression. In this case, we're just trying to print out the value of score. Score has no value because we haven't initialized it to anything. So we can actually go in here and we can modify that. Let's just set score equal to 0 to see if we can get the compiler to be happy. All right, compile and run. Oh, okay, this is cool. So we compiled and ran it, and now it says number of touchdowns is 2, extra points is 3, and the score is 0. Now, the compiler is happy. We have satisfied the constructs of the language, but the computer program doesn't know that that score is incorrect. The score is not 0. The score needs to be computed based on the number of touchdowns and the number of extra points. So we actually have to figure out how to do that in our code. So at this point, I would say that our code is syntactically correct, right? It compiles and runs, but logically, it's not correct because we're not correctly computing the value of score. All right, so why don't we actually compute the value of score correctly? So if you were going to compute the score in a football game, and I told you touchdowns, every touchdown has the value of 6 points, and every extra point is just a single point added to the score, how would you compute the value of the score? Well, think about that for a second, right? What is the value of the score? It's probably, well, let's think about it. Every touchdown's worth 6 points. Every extra point is worth 3 points. So I could look at this and I could say, okay, well, that we have 2 touchdowns, that's 6 points each, that's 12. Then we have 3 extra points, so that's 15. So the score is 15. All right. All right, so that seems like it would make a lot of sense. So why don't I compile and run this? Okay, so this looks like it's correct now, right? Number of touchdowns is 2. Number of extra points is 3. The score is 15 because 2 times 6 is 12, or the touchdowns plus 3 is 15. That's really great. Okay, so maybe we could say, hey, all right, we're done with this football program. We figured everything out. Oh, you know what we forgot to do? Right at the top. Not really modeling good behavior here, but I'm going to put my name up here, Bob Dugan, CSC103, section A or B, depending on when you're watching it. Help. This is an in-class exercise. Okay. Okay. So we have a program that is okay, but it could be better. So why could it be better? Well, if I change the number of touchdowns to 3, right? So now we have 3 touchdowns, 3 extra points, and I compile and run the program, I have another logic error again. Number of touchdowns is 3. That's 3 times 6 is 18 points, plus 3 is 21. So I should, wait, yeah, 3 times 6 is 18 points, plus 3 is 21. So I should have a score with a value of 21. Now I can go back and fix that and change it to 21 to get rid of my logic error and compile and run this again. So that's right. But I'd say that the program itself is somewhat brittle. Every time I change touchdowns and or extra points, I have to make sure that I go to score and calculate its value correctly and update that. So the program's okay, but what would make it even more powerful, more flexible, more awesome, and more like a real computer program is if I could change line 15 so that when the number of touchdowns changes and the number of extra points changes, a new score is automatically computed. So let's put another way, I'm going to compute the value of score based on the values of touchdowns and extra points. So how would I do that? Well, let's get rid of this hard-coded number 21. I'll add some spaces here to make it look a little nicer. And think about this more like a formula. How do we compute score? Well, we compute score based on the number of touchdowns multiplied by 6, right? 6 points per touchdown, plus the number of extra points multiplied by 1. All right, I guess the multiplied by 1 is a little extraneous. So that looks more like what you might write down on a pencil and a piece of paper. You know, in an algebraic kind of formula, you wouldn't have this int over here on the left, but everything else, I mean, if I get rid of int for a second, that looks like a formula you might write down on a math homework assignment, right? You might change this x, you might use a dot instead. Of course, the dot would be in the center. Let me just put that int back here. Okay, so this is looking more flexible. Now I'm not going to compile it because I just want to tell you that this x here that I just used that looks like a multiplication symbol, that's something you'd be used to using in a math homework problem. Yeah, it's not going to work in Java. Java thinks that x is a variable, and it's going to get very upset if it sees it in an arithmetic expression unless you've declared the variable x. But it doesn't know then, you know, does x mean multiply? Does x mean the variable x? So in Java, x means a variable x. So we have to have another symbol for multiplication. So the symbol for multiplication is an asterisk. So that stands for multiply. So then now we have score equals touchdown times 6 plus extra points times 1. All right, let's run this again. Compile and run it again. Cool, number of touchdowns is 3, number of extra points is 3, and the score is 21. Awesome. Now, if I go back to the football program and I change the number of touchdowns, and let's say we just make it 5, right? 5 touchdowns and 3 extra points. So in my head, I'm doing a calculation and saying, well, the number of touchdowns is 5. That means we have 30 points from touchdowns. Number of extra points is 3. That's 3 additional points. So 30 plus 3 is 33. So hopefully, if this formula is correct, then we should see a score of 33. Let's compile and run it. Oh yeah, we did. Number of touchdowns is 5. Number of extra points is 3. And the score is 33. Hey, this is awesome. All right. Now, let's see if we can improve this just a little bit more, before we start to talk about writing programs in general using variables, data types, and IO. So there's two more mechanisms for improvement that we can do here. So the first one is this times 6 and this times 1 is a little confusing, or it could be confusing because they're just numbers, and it might be hard for someone who doesn't know anything about the program you wrote, or it might be hard for you if you come back a little bit later, let's say a couple months later, and look at this program to remember what that 6 and what that 1's for. So we could add a comment here. All right, so there's some comments that are little clues that are saying, hey, for 6, the number of for touchdowns, the number of points per touchdown is 6, and for extra points, the number of points per extra point is 1. So that explains the mystery of what this value 6 is and what this value 1 is. Now, at this moment, at this very moment, you might be thinking, that is so obvious. I would never make the effort to put those comments in my code to remind me what these numbers are. But believe me, a few months from now, you will have forgotten that you wrote this program. You will have forgotten what's on line 17 and what it means. So it's really nice to put that information in your code as a little notation. And someone else might have to be fixing your program. And so if they go to look at your program and they see your comments about the formula here, they'll be really grateful that you had those comments. So that's one way that we could make this line 17 a little more readable or understandable. Another way, though, is we could add something called a constant to the program. So a constant is you use the word final. So if you say final int points per touchdown equals 6, and then final int points per extra point equals 1, what you're basically saying is these are values, these are variables that never change their value. So points per touchdown equals 6, points per extra point equals 1. These are constants, and you can take those constants and you can use them in expressions that involve computations, like now what's on line 19, the int score equals touchdowns times 6. So I can change this touchdowns times 6 to do points per touchdown. This is a nice autocomplete there. And points per extra point. Now take a look at this equation on line 19 now. Int score equals touchdowns times points per touchdown plus extra points times points per extra point. I would submit to you that this expression on line 19 that computes score is very readable, is very easy to understand. We don't even need these comments here anymore. I'm just going to delete them because they're pretty obvious how it works. And if anything ever happened in the future and the points per touchdown changed, like it wasn't 6 anymore, it was some other number, you could change line 11. And the same thing with line 12. If there was a point in the future where there was some rule that changed the rules for the number of points per extra point from 1 to some other value, you would be able to change that as well. The one thing that if you're a football expert, you know that the number of points per extra point varies depending on, or the number of extra points that you get for a particular field goal varies depending on the situation. And there's some other things around extra points. So I don't want to really get into that. So we'll just say the points per extra point is 1 right now. But if there's something weird happened in the future and you can get more points for a single extra point, you can change that number from 1 to something else. Now this final is really special because what it means is that you're making a promise that for the duration of the program after line 11, the value for points per touchdown will never change. So it's something that we call a constant. It's a variable that never has its value change. And the same thing with what's on line 12. If you make an attempt to change it, like, you know, we're changing the value of score in this expression on line 17. I guess we could just to demonstrate that. Well, I don't want to get things too confusing. So if we were to try to change a final, just put it that way, a variable is declared as final, it means you're breaking your promise. So right here on line 18, if I were to say points per touchdown is equal to 5 instead of, or let's say is equal to 10 points per touchdown instead of 6. Let's see what the compiler says. So the compiler says error, cannot assign a value to a final variable points per touchdown. So it's saying you're not allowed to change the value of points per touchdown because we have points per touchdown. We're making a promise on line 11 that we're never going to change its value. So let's get rid of that on line 17. Shouldn't be changing its value. All right, we have a really nice looking program here. So what I want to do is click compile and run. Oh, look at that. Okay, so everything compiled and ran okay. We still see the same output. The number of touchdowns is 5, the number of extra points is 3, the score is 33. So we still see that. It's just that the underlying code that makes it all work has been revised several times and improved to make it clearer, more powerful, more flexible underneath the covers. So even though the end user, the person running the program, would never see all of the code that you wrote to make the program work, we really have a nice looking program. The only thing that I would want to change about this program to improve it just a little bit more is I want to make the program flexible enough so that we can get some information from the user. Because wouldn't it be nice for the user to tell us what the number of touchdowns is and what the number of extra points is instead of hard coding it in the program? Because right now you could, if we just go back to here, right now you could email this program to a friend of yours and say, hey, you know, or your mom's like, hey mom, check out this program I wrote, or hey dad, check out this program I wrote. It's a football program, it's really cool. And they could run it and they'd say, well, that program's really nice, but every time I run your program, I'll just run it again, Java football. Every time I run your program, it always says the score is 33 because there's nowhere for me to change the number of touchdowns and the number of extra points. And you're like, oh yeah, there is. Let me mail you the Java file and show you this code. And they're going to say, wait a second, I am not taking this computer science course with you. I have no idea what any of this stuff means. I'm not sure what to do here. I just want to run your program. Is there some way when I run your program that I could tell the program what the number of touchdowns is and what the number of extra points is without editing the code? And there is. That's called input. So you can get input from the user and let the user tell the program the number of touchdowns, the number of extra points, and then we'll have the program compute the score. That would be a much more flexible version of the program. So let's do that. So the way we're going to do that is if you want to get input from the user, then what you do is you just have to add just a few lines of code. All right, so I'm going to show you the code that you add. You're going to add this line, scanner input equals new scanner system.in. Okay, so that is just weird gobbledygook. In fact, I would say there's a lot of similarities between this weird gobbledygook here and this weird gobbledygook here. It's just a lot of weird looking stuff, words that look vaguely like they're English, but what does it mean? And what I'll tell you what it means, we will unravel this as the semester progresses, but line 13 is basically saying, hey, Java, I would like a mechanism for getting input from the user. That's basically what it's saying. All right, now, if we want to get the input from the user, we're going to modify line 16, okay? And on line 16, we're going to say, enter the number of touchdowns, colon. We'll get rid of this. All right, and on the next line, on line 16, we're going to say touchdowns equals input dot new dot next int. So what line 16 says is go out to the computer keyboard and get an integer from the computer keyboard. All right, so there's an expectation that the user is going to type an integer in while the program's running and press enter. All right, so we're going to do the same thing on line 18. Enter the number of extra points. And get rid of that. And then we're going to say extra points equals input dot next int. All right, so go out to the computer keyboard and get an integer. And now that we have touchdowns that we just read in from the user and extra points that we just read in from the user, then on line 21, we're going to compute touchdowns times points per touchdown plus extra points times points per extra point. We have a super flexible program now that no matter what number of touchdowns and what number of extra points get entered by the user, the program correctly calculates the score. Okay, so let's do compile and run. Oh, there's an error. It says it can't find the scanner. So scanner input equals new scanner system.in. All right, let's go back to, so we have a syntax error. And it's basically saying there's something missing on line 13 or something that's incorrect on line 13 that we have to fix. So that thing is a special statement that goes up here right up at the top of the program. You have to type this, import java dot util dot scanner. All right. And that basically says, hey, Java, go out and find that special code that makes keyboard from input from the keyboard work in a program. So that's what this is saying. And this is saying, hey, Java, get things set up to read from the keyboard. And this is saying, hey, Java, read an integer in from the keyboard and set touchdowns equal to that integer. And this one says, hey, Java, read from an integer from the keyboard and set extra points equal to that integer from the keyboard. All right, so we'll compile and run. And now we don't have a syntax error anymore. And we're now getting an interesting piece of text here. Enter number of touchdowns. And the cursor is just sitting there. Now, why is it doing that? Well, let's take a look at our code. Our code says enter number of touchdowns, and then it says go out to the keyboard and read in the number of touchdowns from the user. So right now, that's what's happening. The computer is waiting for me to type the number of touchdowns. So let me type, let's put in a crazy score, 10 touchdowns, it's just a blowout game. All right, immediately after reading in 10 touchdowns, it says enter the number of extra points. Let's go back to the football program. Touchdowns now has the value of 10. And we just entered the number of extra points. We now see this prompt, enter the number of extra points. And now the computer is waiting for me to type in an integer, and it's going to set extra points to that integer. 5, let's say 5. So if we have 10 touchdowns and 5 extra points, what will the score be? Right? If we have 10 touchdowns and 5 extra points, what will the score be? Well, each touchdown is worth 6 points, so 10 times 6 is 60. Every extra point is worth a single point, so we should end up with a score of 65 if the calculations are correct. Oh, and there we go. It says the score is equal to 65. Awesome. All right. So let's go back to code here. I'm pretty happy with how this all worked out. And I just want to review what we've looked at. And then I'm going to make sure that this code's available for you immediately after this video segment, because I want to make sure that you have a working version of the code. Here's what I don't want you to be too frustrated with. If you were following along and you were typing things as I was typing them, and then you compiled your code and you got some kind of error and you stopped the video and you went back and you tried to fix the error and you really weren't sure how to fix the error, that's okay, right? We just did a lot of code. And if you didn't get it quite right, that's fine, because right after this video, I've got a copy of the working version of the football.java program with everything that we've written here in it. So you can chill out. You're going to have that copy to use. It might be a worthwhile exercise, though, to really deeply compare every line of code that you have to the lines of code that I have in this program. Because if it's not working, there's something that you did wrong. And it could be really subtle, right? Every choice and change in case, every semicolon, all the spacing, everything that I've done here has to be just right, or you run the chance of having some kind of error. Also, you should take a close look at the errors that are being reported in the terminal window when you attempt to compile and run your program if you're getting an error, because it will often give you a clue as to what is the problem. So between those two, hopefully, plus looking at the correct program, maybe you'll see what your error is. If you're really stuck and you're frustrated and you want to figure out why your program doesn't work and my program works, you can shoot an email out to me and I will, with your program, and I'll be happy to look at it and give you some feedback as to why your program might not be working. But let me explain what we're going to do next. So you're going to have this working version of the football program available to you. But what I want to do now is I want to step back from a specific program. This is football, which is an example of a program that uses variables, data types, and I/O. And I want to step back and look at just some generic aspects of writing programs that use basic variables, data types, and I/O. So that'll be next.